Hello students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from ILS chapter in Keith Williams' Radio Navigation book. So let's start. So 71. The back course of an ILS may give what? So remember, the front course of your ILS system will give you normal sensing of the needle, normal sensing of CDI needle. That means you follow the CDI indications. You follow the CDI indications. If you follow a back course ILS, you will be getting a reverse sensing of the CDI indications. So in that case, you do not follow the ILS or CDI indication. Okay, you do not. So if the CDI tells you to fly left, you do not go left, you go right. You do opposite of what CDI needle tells you to do. So a front course ILS will be a precision approach performed on a precision runway. Why a precision approach? Any approach that has uh, horizontal guidance and vertical guidance, both horizontal and vertical guidance in the form of localizer and glide slope transmitter will be called a precision approach, and that particular runway will be called a precision runway. A back course ILS will only be able to provide lateral guidance with the use of localizer antenna, which is not meant for that particular runway, but still. So it will be called a non-precision approach, and that runway will also be called non-precision runway. Non-precision runway. So the back course of an ILS may give precision approach guidance. No, there is no glide slope available, so not a precision approach. So Charlie is also eliminated. Bravo. Non-precision approach guidance to the main approach runway. Non-precision approach guidance for the reciprocal of the main approach runway. Delta. Okay. So it will give you non-precision approach for this non-precision runway. Runway 09er. Runway 27 is a precision runway. Okay, so this localizer antenna is primarily meant for providing ILS guidance for this runway 27, not for runway 09er. But if you are using that localizer antenna for runway 09er, then it will be a non-precision runway. And therefore, we say non-precision runway is nothing but the reciprocal of this precision runway or the main runway for which that ILS localizer antenna is established. Right? So back course ILS. Here the aircraft is right on the center line of this runway. So the CDI needle is in the center. But when this aircraft deviates to the left hand side, okay, the CDI needle should show a fly right indication. But look, the CDI indication is showing fly left indication. Similarly, when aircraft deviates to the right hand side, the CDI must show a fly left indication. But over here, the CDI is showing fly right. So in back course, you do not follow the CDI needle. You do the opposite of what it says. Okay. Next. Which answer states the typical distances along the center line of the runway? So remember, first let's address the marker beacons. The outer marker is 6.5 to 11 kilometer from the runway. The inner marker is 1 kilometer middle marker, and the inner marker is 75 to 450 meters. Okay, from the runway, very close to the runway. After that, let's say this is a runway. Okay, this is your north datum. So this is runway 36. This is runway 18. All aircrafts are landing on runway 36. The runway 36 is in use. So departure from runway 36, landings on runway 36. So for so if there are ILS operations available for runway 36, the localizer transmitter will be situated on the opposite end of the runway. So the localizer for runway 36 will be situated at the opposite end of this runway. Okay, and the distance will be 300 meters away. Glide slope transmitter. The glide slope transmitter will be 300 meters from the runway in use, from the end of the runway that is in use. So runway 36 is in use. So from this runway at a distance of 300 meter, the straight distance and horizontal distance 200 meters. So here will be your glide slope transmitter. So localizer transmitter directly opposite. Glide slope transmitter 300 meter down, 200 meter right hand side. Okay. So localizer transmitter 300 meters behind the end of the runway, yes. Glide path transmitter 300 meters behind the threshold. Middle marker 1000 meters from the threshold. Outer marker 4 nautical miles. Localizer transmitter 300 meters behind the runway. Glide path 300 meters behind the threshold. Middle marker 1.5 nautical mile from the threshold. Outer marker 10 nautical mile from the threshold. Localizer 100 meters behind the runway, no. Localizer 100 meters behind the runway, no. So we are left with option alpha and bravo. Now here they say middle marker is 1 kilometer from the threshold. So this is right. 1000 meter is 1 kilometer. Outer marker 4 nautical mile. So 6.5 kilometer is equal to how many nautical miles? 6.5 divided by 1.85 is approximately 3.5 kilometers. So option A will be the right option. Next. The ILS marker identified by a series of alternate dots and dashes is what? Alternate dots and dashes. So outer marker is identified by 2 dashes per second. Middle marker alternate dots and dashes 3 per second. Inner marker 6 dots per second. So alternate dots and dashes belong to the middle marker. Okay. Next. The ILS marker with lower oral frequency. So for outer marker, the oral frequency is low, pitch is low, more frequency is 400 Hertz. For middle marker, frequency modulation is 1300 and pitch is medium. For outer marker, frequency is 3000 Hertz and pitch is high. So the lowest frequency belongs to the outer marker and the lowest tone also belongs to the outer marker. So the correct answer here is outer marker, option A. Next. Beam bends. Now beam bends are nothing but scalloping, which is nothing but the bending of ILS signals around objects, obstructions, buildings, mountains. But bends is scalloping on a small scale. Scalloping happens on a large scale. And when this bending of signals happen on a small scale, we call it beam bends. Okay. So either phenomenon, what happens? So either of them we always encounter rapid movements of CDI needles left and right. So in case of scalloping, you will not be able to follow that CDI needle. But in case of beam bends, the CDI needle will move rapidly left and right, but still your aircraft will be able to follow them reliably. So beam bends are curves in the normal approach because of noise abatements. No. Curves in the glide path that are visible but change too fast to be followed by large aircraft. Curved approaches made with the aid of ILS, slight curves that can be followed by large aircraft. So option delta, they are slight bends. Okay. Locators. Now what are locators? Locators are low powered NDB stations which replace the outer marker. And this compass locators or locators will help your aircraft navigate inbound towards that airport. Okay, so therefore they are called compass locators. So they are low medium frequency NDBs used as an aid for approach for going inbound, right? So option alpha is the right answer. And the range of them is 10 to 25 nautical miles, not 10 to 250. So this is wrong. And they are low powered, not high powered. And they are NDB stations, not ADS stations. So there is a difference. The UHF band is belongs to what? So Correct answer is option alpha. The glide path transmitter operates in the UHF band 328 MHz to 338. ILS localizer operates in the VHF. Marker beacons also operate in the VHF. So alpha is the right answer. Forming an ILS approach, you fly overhead the markers in a specific order. So first you will fly outer marker, middle marker, then the inner marker. Okay. So the correct chronology is outer marker, middle marker, and inner marker if that is available. The type of modulation used for ILS frequency is amplitude modulation. Okay. So your ILS localizer glide slope transmits on main carrier frequency. In case of localizer, it will transmit in the VHF band. Glide slope will transmit in the UHF band. And this main carrier frequency is further amplitude modulated 90 Hz, 150 Hz. Okay. So it's amplitude modulated. In an ILS concerning the localizer principle, the difference in depth modulation. So when you are right on the center line, the difference in depth modulation will be zero. When you deviate left or right of the center line, the difference in depth modulation will increase linearly. So the difference in depth modulation increase with displacement from the center line? Yes. Decrease with displacement? No. Increase with left displacement, decrease with right displacement? No. Increase from center position to half full scale and then decrease again? No. So option alpha is the right answer. Now option question 81 is similar question. So I have joined them. This talks about glide path. So same principle applicable to glide path. If you are correctly on the glide slope, the difference in depth modulation will be zero. If you are above or below the glide slope, the difference in depth modulation will increase linearly. So increase with displacement above or below the glide path. So option A is the right option. So this concludes our lecture. I hope you have understood all the questions that I have answered in this video lecture. If you have any questions, doubts, let me know in the comment box. Keep practicing these questions again and again. ILS is very important for your theory as well as practical. So learn the theory, read the theoretical chapter, and practice many questions. See you.